with the graduate school now technically part of the provost's office. How many of you knew the graduate school moved? Okay, graduate school moved. Used to be part of the research office, now with provost. So my title has changed, but I have the same job. And we're going to continue doing these graduate training series. We think these are valuable. The feedback we got from the students has been good. Apparently, we chose a really good topic today because we've had somebody who's visual on this. So that's good. Any of you who are doing research are probably going to be collecting data. And once you collect the data, that's the first step. That's can be one of the fun steps. And then the other fun step is actually playing with the data, figuring out what they mean. For me, that often involves visualization of some sort. Humans are visual creatures by and large, and so we can respond to those cues. We can pick up a lot of information visually. And so visualizing data is something which I think is a fun part of the process of doing science, doing inquiry. And so I'm excited to see what three people who are heavily involved in this sort of thing might have to say about it. Quick announcement, the next GrTS after this one is March 27th. The topic is tips for persuasive public speaking. And my question for you is, what do I have to say to convince you that it's worth going to that? The next, supposed to be some humor in there. The next graduate student social. How many of you have been to a grad student social? Not a very social approach. Okay, so the next graduate student social is at the country club. There's no fee for admission. There's free food. There's an opportunity to sit and talk to somebody outside of your office mate, your lab mate, your typical neighbor. And I encourage you to start going. So let's jump into today's presentation. We have three panelists today from very different backgrounds. We have Mike Daines, who's from the King College of the Arts, who does design. We have Alexis Salt from the College of Science, the geology department, which is now going to be food sciences, correct? Or not?
Well,
we're still waiting to hear.
I am looking forward to that change, but I don't know.
It's currently geology. It may become earth sciences. And we have Jacob Allen, graduate student from Plant Soils and Climate, who will be talking about some weather-related work in PSC. So I think they're each going to take a little bit of time to talk about the sort of thing they do with data visualization, and then we'll have some time at the end for you to ask them questions for some advice. So we're going to start with Jacob. Take it away.
All right, hello everyone. I am a graduate student, so I definitely don't have the ability to lecture you on what kind of visualization is the best. So I'm going to treat this as a conversation where we're looking at some of my examples, things that I've recently produced, why they're bad, and some improvements I've made, and we can see maybe there's more improvements we can talk about. But earth science is data visualization in earth science is super important because this is about all we do. We make plots all day looking at geopotential height or pressure or looking at atmospheric anomalies, changes in winds. So we're really visualizing data all day because it's such a large data set that we're dealing with. But I'm going to try and make this more applicable to everybody. So this should be a more general, not earth science heavy talk. So some key points. I think the first and most important thing about presenting is knowing your audience. So some of the stuff I'm going to talk about is largely for presenting because I think that's the medium that we talk about science and show our figures most often. Paper writing is also really important and those figures are important, but I spend a lot more time presenting. I don't know about y'all. So I'm going to talk a little bit more about presenting for an audience. And I think the most important part about this is remember what it's like to be them. You know, we always plan for being the person in the front, but I think we often forget what it's like to be the person sitting, and we can often get bored, we can get distracted, things can be really unclear in a presentation, and I don't think that's the audience's fault in not understanding. I think that's the presenter's fault in not displaying figures and not showing things clearly enough. Break the mold, blast off from boring. I know that's pretty cliche, but I think science especially could take a note from business and marketing and art and really work on how we visualize and look at data and make it look nicer. And finally, my last key point is I think a figure should stand on its own. So without reading a paper, without context, obviously context is super helpful, but without those things, a figure should still be able to tell a story and give a lot of information. Give information that words really can't. That's why we use figures. Okay, so I'm going to show you, this is just for presentation. This is something, I think I could do that introduction a lot better. We could start with just talking about knowing your audience. Right away, if you're in the audience and looking at that first screen, you would see the other two sections and they might distract you. You may take your attention off of me. So I think while we're presenting, it's important that we focus the attention of the viewer. We can take transparent images and put them on the side so people are still seeing what we're talking about, but we can really move through an idea or a theme by focusing on one single thing rather than on a huge image in itself. And this is really indicative of the fact that we control the focus. When you're presenting, when you're writing the paper, you're the one depicting what the person is going to be looking at. I had an art professor in elementary school who was very Bosnian, had a very thick accent, and he would always say, no white space. So anytime we were making an art project, we were not allowed to have white space on our paper. And that was hard. That was very difficult. It took me 15 years to get out of that. But you notice when I don't have anything for you to see on the board, you look at me. You focus on what I'm talking about, and that's a really good way to incorporate or begin, sorry, not incorporate. That's a really good way to introduce topics. You don't need something on the board. You can just talk about it, and people are going to focus on you, not what's on the board. Okay, so this is an example, and I want you all to just take a minute. This is something I produced in a paper that I'm hopefully publishing very soon. And I want you to look at it and see if it makes any sense. Try and figure out what I'm talking about. I'm not giving you any context, but I want to see if there's anything from this graphic that you can take away. I'll give you a little bit of time then. All right, right off the bat, does anybody get anything from this time series plot? I see a lot of squinty eyes and confused faces.
There's a trend for increasement. That's it.
Great. Okay, so we're seeing, yeah, this random acronym that is not listed. The variance of this acronym is increasing. We can see that. Okay. Do you know what these colored lines are? Ensembles. Okay. So people that have worked with big data might know that, oh yeah, those are ensembles. But is this useful? No, right? Is there anything else? Do you know what I'm studying?
Climate variability.
Okay, climate variability. But what's the other half of that sentence? It says of natural gas in the United States as an indicator of natural gas in the United States. And none of that is shown at all in this image. So this was my Jackson Pollock meets time series analysis plot, which failed miserably. And my advisor made me redo it, thankfully. Now look at this one. Again, I'm not saying this is the best. I'm just saying this is probably better. But anyways, I want to see what you get out of this figure. Any comments? Something that, even if you understand more of a story or a relationship?
The right one is the comparison from the other figures.
Yes.
And the next one, just the deviation of the index in NAWD.
Okay. So, yep, we're looking at that NAWD index, and then the orange line, national natural gas storage, right? So from that, do you see a relationship between natural gas storage and the NAWD, whatever that is, right? So we can start to piece together, there is a relationship between the NAWD, which is a winter climate pattern in the United States, and natural gas storage. And just from looking at that time series, you see that they are following each other not only in trend, but in magnitude as well, obviously different units. So that kind of stimulates the interest of the reader to realize, okay, there's a relationship. What's the next question, especially when we're thinking about climate? We're thinking about what's going to happen in a time of climate change, right? So that's what this ensemble is. And maybe these should be larger. There's definitely ways to improve this image, but we're looking into the future and projecting the variance or the extreme cases of that winter pattern, and then showing because natural gas storage has trended and followed this climate pattern in the past, what can we expect in the future? So that's kind of what the figure is trying to show. Does that work better? I don't know. Better, but yeah, what are some other, this is not finalized, so do you have other suggestions? What are things that would help as the reader?
Maybe just like you said, summarizing that there is, that we're focusing on the relationship.
Good, okay, so context will be really important for that, right? Yeah, so in my figure heading, talk about this as a relationship, or I can maybe work with something in that first time series to try and signify that these two things are related and not separate. Anything else?
Bigger text.
Bigger text, yeah, really important, right? So I just made this, an hour ago, and my text is way too small. People in the back of the room can't read it. In a paper, it might work, but not here. So context.
Also, maybe label your axes is one of the things I was going to talk about. But I mean, you can figure out by working through the figure that obviously we're dealing with time on the x-axis, but years and what are these units over here? You have to go to the legend to find that out. So
absolutely, yeah, because you don't want somebody to look at it and wonder. You want them to look at it and know right away, because their eyes are going to switch straight to the y-axis to look at what is this. Yeah, this is natural gas storage, but you don't know the units. You don't know. Okay, well, units, but it doesn't show right away. So that could definitely be. All right, here's another thing. With climate, we get to look at a lot of really pretty images, which I think makes data visualization super fun, but also often distracting. So this is an example. I'm going to talk about how, we'll just show how this can be done. So how do y'all feel about this first graphic? Do you understand what's happening with the polar vortex? Or are you distracted? They're pretty good, okay.
There's no legend.
No legend, okay, yeah. Yeah, you don't know what are we even looking at, right? We don't know what we're looking at. We don't know what part of the Earth we're looking at either. This is North America, but unless I told you this is a northern polar stereographic view, you wouldn't understand what that is. So yeah, we're looking at Arctic circulation. But again, this is something where I think it's really important because these plots I think are pretty, they can be distracting. So I think in data visualization, I don't know if this is something you encounter in all your fields, but in data visualization, we really need to focus on one thing at a time. This is a complex process of the polar vortex in the northern hemisphere. And this is, talking about this in the presentation is not going to work well if I have two other images up showing different segments of the polar vortex. So I think this is an example that I wanted to show just of focusing attention. Yes, I definitely need to also include what we're looking at. This is circulation. So we're basically looking at wind really high up in the atmosphere and the stratosphere. But if that's not on the figure, you're not going to get that information. So definitely something to add. Okay, last one. Sorry, last exercise.
Both of them has eval less than 0.05.
Yes, ma'am.
Again, no legend. I mean, what is the temperature? What is the conception?
So if we're talking about correlation, that temperature exactly might not be necessary because this is showing, and that's where I need to improve too. If we're talking about correlation and I'm using colors like red and blue, I think people often think temperature right away. Yes, this is sea surface temperature, but we're showing a relationship between the sea surface temperature in this region and natural gas consumption in the United States. So red and blue may not be the best colors because I think we immediately think temperature. Maybe I'm wrong. So to show this relationship better, I could probably use different colors and indicate this is a positive correlation, showing that increased sea surface temperatures drive up natural gas consumption in the States. But do you get does the story make sense just by looking at this image? A little bit more? Yeah, so I guess I just wanted to go back to my key points on these. Know your audience, break the mold, but a figure should really stand on its own. I think this is something when I have to read a paper, and if I look at a figure and it's really overwhelming, I don't get a lot of information from it. Obviously, people need to plot very complex things that represent complex ideas. But I think we, as people presenting, need to work on how to simplify those and make them fit into our story. So the reader's getting something that they get out of that figure that they can't get out of words. So again, I'm a master's student. There's no reason I should be up here talking to you about data visualization, but I learned some things that I can improve in my figures for my paper, and I hope you also took some things away. I think the most important thing is I need to remember what it's like to be sitting there when I'm presenting, and I would like for other people also to remember what it's like to be in the audience when you're looking at science that you haven't seen before. Thank you.
Before I get to my slides, I just wanted to introduce myself. My name is Alexis. I am a professor in the Department of Geology in the College of Science, as Richard said. My area of expertise is a field known as thermochronology. In geology and earth science, we like big words and to combine words together, but embedded in thermochronology is temperature and time. And so my area of expertise is using radioisotopic dating systems to place timing constraints on fundamental earth processes such as earthquakes or when mountain ranges were built. So in my, my research and members of my research group, we use thermochronological, geochronological data every day. And something that Jacob highlighted, is that data visualization in the earth sciences, how we are communicating our science really is our currency. And the examples that I want to show today are a little bit more first order, but just to remind us of some key things that I think we tend to forget as we're beginning to compile figures for manuscripts. And I was focused on the manuscript thing because each of my graduate students, my postdoc, my undergraduate, myself, we were all working on manuscripts right now, right? And an important part of that process is determining the figures that go into those manuscripts and how they tell the story. So this is exactly what Jacob said. He said the figures are so important, they should tell the story. So when I sit down in my one-on-one group meeting with my PhD student, we start to think about a manuscript. I say, okay, depends on the journal, right? Are you short format or you want long format? But let's say, you're going big. It's a Nature paper. You get 3 or 4 figures. The first thing I say to Rob is, what are the 3 or 4 figures that are going to tell this story? Okay. So when thinking about a manuscript, I make the student or the research group member outline that. And then what are the 5 highlights? Because oftentimes when you submit for to a journal, you have to have 5 highlights with that annoying 85 character limit or something like that. It's really challenging sometimes. Okay, and then we do a brief outline. And I say, tack it to your wall. This is important. Okay. So when it comes to these figures that tell the story, there are some first order things that I think it's important to remember. And I have to say the example that I'm going to show first and foremost, some of you will look at it and you'll just go like, oh, we know better than this. But you'd be surprised, sometimes you see undergraduates and graduate students both that forget some fundamental aspects of data visualization, okay, and figures. So what program did I make this plot in? Excel, right? This is one step removed from like the little X's and stars and everything, or the shadows behind them. I hate the shadows. Okay, I actually had to take a plot in Excel and convert it back to something that looked even worse because I'm pretty obsessive compulsive about even my Excel plot. But here we have a plot with data in X and Y space, right? Scatter plot. And what are some issues that you immediately see in this figure? What do you guys see? There's many. Oh, yeah, so what are these axes? okay, you're going from 0 to 100, but what, right? So your axes need to be labeled, okay? We have that problem with both X and Y. And that's just sort of the tip of the iceberg here and one of the most egregious things. What else is going on here that's problematic? It's hard, I'll just turn this off here for a quick minute, but these are actually different shades of red. These are individual data points, so like see these pink ones right here, or in a Valentine's theme, right? We're still on Valentine's Day. But these data points are replicate analyses, okay? Replicate analyses from the same sample. So I've at least binned them by color-ish, but right, you can't make out those different symbols. What else? What else is problematic?
Legend.
No legend, right? We have no legend. So there's a lot of things going on here. Okay, the axes aren't labeled, we're missing a legend, the symbols aren't distinct. Looks like an Excel plot, right? Another thing that certainly is an issue in earth sciences and generally in the sciences, what are your analytical uncertainties on your measurements, and can you represent them on this figure, okay, right? So what I want to do now is show you what this plot looks like after I take it into one of my favorite art therapy programs, which is Adobe Illustrator. You all work with Adobe Illustrator a lot? No? Are you a Corel Draw? My postdoc is Corel Draw. He loves Corel Draw. I'm like, but I don't know. Yeah.
My life is Adobe Illustrator, so yes.
You know what? I used to do art when I was a kid, and now I tell my mom, I'm like, I want to make this figure. Okay, so this is a little bit better, but now you're starting to get some more insight here. I also did add a little bit more data here. Okay, so this is a figure for a paper that I have been working on and needed to submit like 2 years ago. Okay, but on the x-axis, you can see I'm using a really nice Arial font, a sans serif font. Okay, so Arial is obviously our Helvetica works, but figures should be, you know, the font in figures should be sans serif, so no little wings on the end. And there actually are, so this is a chemical proxy right here. This is uranium. And the ppm here is telling you that these values are concentration values. So we have some chemical information about these tiny little minerals that we analyze from rocks that came from actually Arctic Canada, okay? So obviously we now have our axes labeled. The y-axis is time. As I said, I'm a thermochronologist. And so these dates are in MA, which is mega annum. Hundreds of millions of years. These minerals are very old. Okay, so we're going from 0 all the way to 700 million years. A legend has appeared. Here are our individual samples, right? And the symbols are denoting the different data types. And I have classified, again, replicate analyses. Here's our pink. Here's our pink. Replicate analyses by the same colors. So we're classifying by sample and also by data type. The final thing is you can see here, unlike the previous figure, we actually have error bars. Okay, these are straight out of Excel, but they come from our actual analyses. So these are propagated analytical uncertainties. I guess what I want to emphasize about this diagram is that there is a clear legend. There are clear symbols. I like to use the outline, like a 0.25 or 0.5 outline around symbols that are distinctly colored and that you can make out the difference between a circle and a triangle. And this is, again, a figure for a paper. And if I was to talk about these data in a presentation, say at a national meeting or something like that, I would have a different header or maybe no header on the screen at all. But this would take up the entire screen, just like Jacob said. Right? This would take up the entire screen. Right? No need to keep it small. All right. So another thing well, another point to make here, transitioning between this is figure A, this is figure B, is that these are the exact same data, but they can be represented in a different way, and all you have to do is change and have a very clear legend. Okay, all you have to do is change the legend and have a clear legend. So, you know, x-axis, y-axis are the same, the data points are the same, but now I have binned them and categorized these data in a different way, and in this case, it is related to the size of the crystals that we're dealing with. So the reason why I included this example was simply to say that the same data set can be looked at different ways depending on how, like, the key point that you want to make to the reader of the paper. Okay. In this particular manuscript, A and B sit above and below one another in a single column figure. Okay. I mentioned before that I really love Adobe Illustrator. So this is a paper that I recently submitted and is in review at Geology. And Geology is a short format journal where you get 4 figures. So you're trying to pack a bunch in. That's also why this particular manuscript has a 30+ page supplement of figures. So what can we take away from the multi-part figure? Now, if I was giving this as a talk, I would do exactly what Jacob said, and I would maybe build in components if that's what I wanted to do. But sometimes we have to have multiple things, multiple ideas or concepts expressed, loosely linked together within a single figure. So what are some, you guys are like, well, I don't even know what's going on here, but what are some things you like about this figure? And what are some things you don't like?
I like the color of this gray.
Yep.
And the color is more colorful.
Okay. Okay, so visually you can see some things up here sort of belonging together because we've got a grayscale going on. Okay, and then we have colors down here. Anything else positive? Or yeah, go.
The white arrows, the color figures, it's not that strongly like the white arrows.
Yep. You wish they were a little bigger or
Darker.
darker? Okay, yep, exactly. That's a great point. So to draw attention to this. Okay, so is there anything else? Yeah.
I appreciate that it's visuals, even though we read but right, it's still visual.
Yes, exactly. I was just discussing with my master's student, Leah, about figures and how we have to have, she's working on a manuscript, we've got to have A, B, C, D, right, for these multi-part figures. And the other thing is, this is an inset here. The reader can follow very carefully that you've gone from here and you've zoomed, gone right out to here. It's a little bit trickier to say, well, what is the relationship between B and C? That's where the figure caption comes in. Okay. So just a little bit of science here for a second. These are data that were acquired in our microscopy core facility just across this quad here on our field emission scanning electron microscope. These are nanoscale textural, morphological, and chemical observations of a fault surface that based on these data we know accommodated a tiny earthquake. And so we can see these different polygonal textures on the surface using this scanning electron microscope. And we also have an attachment on that microscope that allows us to map out the mineralogy, the orientation of the crystals. That's why this looks like a kaleidoscope. All the crystals are oriented in different directions, and then map that out in what we would call a stereo net. So these data come from a fault surface from Chile. When you're getting into multi-part figures, another point to just make here is that the caption is going to be critical, okay? So a picture is absolutely worth 1,000 words, but you have to spell out for the folks in the manuscript they're reading what they're looking at as well. And it is totally true that you should be able to flip through that paper and look at those 4 figures and kind of get the whole story, but sometimes you need this information within the caption to tell you what's going on here. Because if I annotated the bejesus out of each of these images with stuff, you begin to they lose their clarity and their information, okay? So in manuscripts, in terms of data visualization, Another important point is that the figure cannot necessarily stand alone. Sometimes you need that caption to help you convey points of information as well. Okay. And finally, we can get a little bit crazy with Adobe Illustrator here. This is another figure I made actually for this same paper. And there is a lot going on here, right? This is related to the evolution of one of these fault surfaces, okay? But I guess what I would ask you all is, what do you like about this multi-part figure? And also, what do you think is going on here? It's a schematic, but what is it?
So the temperature and sleep velocity with respect to time, like how it's changing.
Yes, this is a time series, right? So we have a time series, and I wanted to represent certain variables and how they evolve as a function of time as this fault surface is developing. We've got temperature, which is the red line, slip velocity, right? So we're dealing with a fault surface that's moving. And then we also have another y-axis variable here, shear stress. And this is schematic. Note there are no values, right? So sometimes, you know, diagrams can be schematic and they can lack values but still contain information. I tried to couple the evolution of these parameters as a function of time with some kind of visual representation, okay? By saying here's 1, 2, 3, and 4, and here's 1, 2, 3, and 4. This final one is just taken this and popped it open so that you can reveal that unique web of textures on the surface of the fault, what we call fault mirror. But when I was conceiving of this figure, I had to figure out how am I going to break out not only the diagrams, but also how these parameters are changing. Because this is, people want to ultimately know, what do you think is happening with temperature, with slip velocity, with shear stress on these surfaces as the textures that you're observing evolve? Is there anything that I could do differently here and do better? It was tricky to me. This legend here kind of belongs with this. So how do I do this without making the figure expand? Right, so I tucked it up there. Maybe there's too much text over here. I don't know, a little too much text. Yeah, in the back. Okay, so maybe I could have had one with a circle around it or something like that, and had a similar, like keep the symbols consistent, right? Keep the symbols consistent. That's a great suggestion. What else? Anything else? Okay, so just for my portion of this to wrap up, I want to emphasize that when you are making figures for a manuscript, you want them to be able to stand alone, okay? That there are fundamental aspects that every figure must contain: axes labeled, a clear legend, distinct symbols, right? And it can be really tricky. So for example, right now, my PhD student is working on a manuscript, and he has so many different data types and different samples. How do you show all of that? Like, do you vary the symbol? Do you vary the color? Do you vary both? And the answer is, it takes practice. You actually have to make multiple drafts of figures and bring them into your advisor and say, what do you think of this? You know, so the iteration that goes into a figure is huge. This particular figure, I've made multiple ways, and I literally changed it like 12 hours before I submitted the manuscript, one final. Okay, so With each successive iteration, you're figuring out what works and what doesn't work. If you have a multi-part figure, you need to make sure that you can walk the reader through very carefully using your A's and B's, your boxes, arrows that could be better defined, okay, to highlight key things. And you need to connect that with a caption, okay, that is informative and spells out each component of the figure. Okay. Any questions? Okay, awesome. It took a while.
Okay, I've had this laser pointer in my pocket, but in my defense, I did offer to let you but I'm gonna see if I can put this to work. So, I don't use PC, so I just wanted to present you.
There's a little.
There's no.
See, click on this button right here.
Okay. Wait a minute. Okay, there.
Yeah. I'm not a PC person either.
Okay, cool. It works. All right. Okay. So these have been great presentations, and it's interesting to hear different takes depending on the different areas of research. So to give you a little bit of background, so my name's Mike Daines. I teach graphic design, and I am a practicing graphic designer. My research focuses largely on client-based design work. So to give you a little bit of idea of what a graphic designer does, because you've probably heard the term, but some of you may have a vague idea of what that is and how does this relate to data visualization. A lot of graphic designers actually call themselves communication designers. So if you think about that, really everything I do is visualizing data in one form or another. My background as a practicing designer started as a publication designer. I designed magazines. And then I got into brand identity design, and I still do quite a bit of work with brand identities for clients, whether they're like corporate or in the arts or institutional. I've also worked in motion graphics, so designing graphics for motion in film and television. I have some experience with that. So, but specifically when you say data visualization, even though I could say, well, everything I do is data visualization, I get that it has a very specific connotation. And when I was asked to speak on this, I knew what, generally speaking, what this was about. So I thought, okay, I want to find some of the most, so let me back up a little bit. As a graphic designer, typically, if we are hired to work in the data visualization process, it's usually like, for instance, when you said, okay, what was wrong with this? And it's like, it looks like it's in Excel. Somebody will come to a graphic designer saying, this looks like it's in Excel. We need to put this, publish this in a textbook or a magazine. We need this to, and they hire us to put on that like extra polish. So it has to look really beautiful. Like that's what they expect us to do, okay? So part of it is effectiveness, but as a designer, we're also thinking about beauty and like how do you stylize things in a way that elevates them beyond just like, an Excel sheet, okay? So I want to talk about some of the principles that I think of when designing data, but I'm actually not showing you my own work. I'm showing you some beautiful examples that I found out there that are great examples of doing this. Okay, so Edward Tufte, he is sort of the father of information design, and he wrote several books, and he's kind of a pioneer in data visualization. And this was back in like the 40s and 50s. And something he said that he wrote in one of his books that has always stuck with me has to do with the idea of what we call in design as visual economy. There is a visual economy. Can anyone think of what that might mean? Like, what do you think of when you think of the word economic or economy? In different contexts, it means slightly different things, but what are some things you think of? If something's economic, what is it? Any ideas? Yeah.
Subject to diminishing returns.
Okay, so subject to diminishing returns, yes. Any other thoughts?
Marketable.
It's marketable, okay. I think in general, an economy is where like, if you talk about diminishing returns, there is like supply and demand, and that determines a price of something, or how much of this there is determines what that price is. If you think of an economic car, for instance, what is an economic car? An economic car is one that doesn't cost too much money, right? A car that has good gas economy gets a lot of gas mileage. So I guess that's the context I'm most specifically talking about. There is a visual economy that determines like the scale of things that we look at and what sizes those are. For instance, I teach classes on typography or using typefaces, so I like that you mentioned Helvetica. Okay, Helvetica is sort of universally accepted as the most economic typeface ever created on the face of the planet. And what I mean by that, it is the most simple yet communicative typeface. There are no frills. There are no, nothing to distract you from the message. And so graphic designers worship Helvetica. We made a movie, there's a movie called Helvetica, which is a bunch of graphic designers sitting around talking about how amazing that typeface is. But it is very economical, okay? There's no excess visual waste. So what I like to talk about with my students in typography is typically when you are used to writing papers, for instance, what do you learn? You learn to use 12-point type, right? Like set it in 12-point type. However, if you pick up a professionally designed publication, you'll actually realize that you have been reading 8 or 9-point type your entire life. You just didn't know it, okay? If you were to set a magazine in 12-point type, it would waste a lot of space because type doesn't need to be that big to be read, okay? So this is the principle of visual economy, is how big does something need to be effective? And in design, we consider that to be the appropriate size for that thing. So in the first presentation, we talked about type size. We were like, well, this type could be bigger, but if it was printed in a book, it would probably be appropriate. But because the format here is a screen, it's not quite working, all right? So you have to think about the format, but within there, there's economy. Okay, so now I want to get back to Edward Tuck. He talked about the principle of using the smallest effective difference, okay? This goes to visual economy. What's the smallest difference you could make when visualizing data that is still effective, okay? Because then that creates a certain visual economy. And so now I'm going to show you some examples of really beautifully designed data that follows this principle. Okay, so this is actually a book about data in London. And it's a really beautifully designed book. There are several really amazing data visualizations. This one in particular, in London, they put these blue plaques up on buildings where famous, influential people who have lived in London are, okay? So this graph actually is documenting all of these plaques, who the people are, how long they lived, the period of their life that they lived in London. The dot represents the period in their life where they became well known for that thing, and it graphs them on this really beautiful graph. Okay, so if we talk about visual economy, notice how this is printed in a book, okay? So once again, the format is not necessarily like for a screen, but if you were to have that in a book, you could see it on a level where the sizes would be appropriate. But for instance, probably a non-professional would be uncomfortable setting type that small, okay? But in a book, you can actually read printed type very effectively, even at small sizes. So, but then also using color in an economic way, okay? So, for instance, this dotted line, you could have used black, all right, instead of gray. If you would have used black, this whole thing would become a lot busier and a lot harder to look at. But because the things that weren't as important are diminished, like visually, the things that are important take more precedence. So actually the type stands out because that's the interesting part that you can read. This point in their lives where they actually became well known is important. So that's represented by a dot. And then this point of their lives where they lived in London creates emphasis by being like the darker blue, and it's contrasted with the lighter blue scale of the person's lifetime. So all this sort of comes together in a really beautiful way, but it's like knowing when to be subtle with color and with type. However, a really important thing is it still needs to be effective. So you can't just use a really light color if you can't see it and you can't read it. And for instance, if it doesn't create enough differentiation between two data points, that's really important. Like I think Alexis showed us the one where those colors of red were really too close to make any real distinction, so they were no longer effective, right? But then once you get to that effective point, if you're subtle about the moves you make, it actually creates something that is not as complicated to look at. This is another example from this same book. This is another graphic about commute times and lengths in London, okay? So they used basically like these transparent white lines, and when those things get laid over each other in succession, it creates these really hot white spots that you can immediately, if you read, once again, combining a description with an image creates like a nice overall picture. But if you read this, you can pretty quickly pick up what this is visualizing. Okay, but also notice the subtlety of like the names of the different cities in England that are surrounding London, okay? You could have made those massive, and typically, like when I work with clients, they want everything to be big, right? Because they're like, well, make this big and make this big and make this big, but you can't leave this out, make this big, make this big. What that actually does is it creates so much distraction that there's no emphasis on anything. So choosing which things you want to have emphasis. So here, because of the opacity they use for those lines, it created these hot spots where there is like high traffic. But then once again, it created an overall really beautiful image. So another thing is how to use color properly. That's something that designers deal with all the time. And because we're hired to make something look really beautiful, so we have to really understand how colors work. One sort of rule of thumb that I like to use is to group colors into families. Like for instance, this entire, actually if we go back here too, it's using this blue palette and it's certain shades within blue. Here, it's also using these cool colors and then one accent color that is complementary that really adds emphasis. So you can create differentiation within a similar color family, and then you can use like one color to create emphasis. And that's a really effective way if you're not familiar with using color a lot. If you use that rule of thumb, that can help you create really nice color combinations. So this is just a close up. So this was actually an app that was designed to display information about app usage. But once again, you can see how using color, like using the cool colors and variations within the cool color, and then this complementary color really brings emphasis in certain areas. And this is a really great example of the smallest effective difference. So I can actually pretty clearly see the differentiation between all of these different lines of data that are being represented, but they still, it's not an obnoxious amount of color. They're all within the same family, and it creates a really beautiful graphic. Okay, so here's a couple examples that I don't think are working as well, and we can talk a little bit about why. But for instance, over here, this was a graphic that somebody made about media and where it sort of falls on the liberal conservative spectrum, and it was their attempt to map all these things out. Okay, so there's several things I think here that are working against it as far as it being a beautiful, like a really nice thing to look at. Okay, you could argue, like, I actually can look at this and get the information I want out of it, but obviously there's a difference between this and something that looks like this. Okay, so, and as a graphic designer, it's my job to make things look more like this and less like this. So one is all of these pieces of text are roughly the same size. So they're in a way, they're creating a distraction because there's no real emphasis. Also, if you'll notice, all these logos were just put in their actual color, so it creates a lot of competing colors. Where on this graphic, they actually are using logos like Apple, Android, BlackBerry, but they've actually made them all blue. Okay, so it still fits into the color palette. And just in general, like, once again, this using typography like this is a bit of a distraction. It makes things look unprofessional. So if you don't know anything about typography, take the Lexus's advice, use Helvetica. Helvetica is simple and professional. My rule of thumb that I tell my students who are just learning about type is, if it looks boring, it's actually probably very professional and a great choice. And it's probably a typeface that has been developed over at least 100 years. If it looks fun, it's going to be an amateur distraction from whatever you're trying to do, okay? But our knee-jerk reaction is to create something that looks fun. It just is, okay? I don't know what it is, but we want our things to look fun. So you're gonna go through your typefaces, find the fun typeface. Really what you want to do is find a professional typeface, and that's gonna be a more simple one. Okay, so over here, I want to show you an example of, like, these colors are too close to each other to be an effective differentiation. So then when they're graphed here on this graph, you see how they just blend together and create something that's really muddy and not discernible. And this is the last slide I'm going to show you. Here, the colors, they're using just a lot of different random colors. And if they were to pull those colors together a little bit more, and for instance, maybe use differentiation within a set of warm colors, and then maybe one cool color, that would create emphasis and not be as much of a visual distraction overall. And another thing, like type size. You can see that this type begins to be stacked right on top of itself. If they were to pull this type out and possibly make it smaller, it could be more effective, depending on the format that it's used in. So that's my presentation. Does anyone have any questions? Yeah.
I guess it's for both of you, but I'm just starting off and my figures kind of look like the Excel figures that you showed. So where's a good place to start and what resources are available?
Go ahead.
Yeah, so I guess what,
Especially, I don't have a graphic design background.
no, well,
But I know it's important.
I do think it's important, if you are, first of all, what type of data are you visualizing?
Mostly, yeah, human data, neuroscience stuff.
Okay, well, so as I mentioned before, I think you probably all have got the message, I love Adobe Illustrator, but that is a program that you can get access to through USU, and that the IT folks, they're excellent. They will help you get that set up on your computer, right? And what you can do when you have Excel open is you can copy and paste a plot into Adobe Illustrator, and we call making it a layer. And it sits there, and you can lock that layer, and then you can start adding layers where you draft over it. Okay. Excel has come a long way such that it used to be I'd have to redraft literally the entire thing. But now you can make certain changes that you don't have to. You can get the line widths the way you want them, the thickness, the kinds of fonts. So it has come a long way. But it's about bringing that Excel plot right into Illustrator, creating a new layer that I always call my overlay, and I start to literally draft over it. And that just takes a little bit of time. But for example, I can show you an example of this on my computer afterwards if you'd like to see how I would do that. I'm happy to do that. I teach a communicating geoscience class to our undergraduate majors, and we actually do this very exercise so that they get an introduction to Adobe Illustrator. They learn how to transfer things from Excel, how to make plots in Excel, how to transfer them into Adobe Illustrator, how to do some basic drafting skills. And I have to say, one of the young people in the class, she just recently submitted an ERCO and a Peak Fellowship, and this, and like, she had these epic Adobe Illustrator figures. So it's something you can pick up on and learn and geek out on.
And also, Adobe has amazing tutorials online. So, like, I think it's Adobe X, but if you just look up Adobe Illustrator, they have really amazing how-to programs that can get you going like pretty quickly. It's not a very complicated program to learn, actually.
I'm going to take advantage of my role as moderator here to put in another plug here. We've seen some cool data, some cool images, and some of the ways that you can use modern computer technology to deal with huge data sets like climate data. Very complicated sorts of things. And I just want to go back and point out that you don't have to use those things to create incredible graphics. So you go back to like the time when I was a graduate student. How many of you have ever heard of Napoleon? Not the thing for bakery. So this has been referred to as the best map ever made. And maybe modern day graphics designers don't agree with this, but I think it's really cool. This is a map showing Napoleon's invasion of Russia. And so it's a map in the sense that it's showing space. East, west, north, south. It's showing the number of people in Napoleon's army that were alive at various points along this invasion into Russia, and then the return again. So here's the number of people that were alive when he started. Here's the number of people, like 4,000, that were alive when he returned from the Skill invasion. So it's showing space and time and number of people, and it's showing temperatures. And the point here is these temperatures are linked to particular dates and places with temperatures of minus 30 degrees, which is a big reason why this black line gets so narrow as you go back down here. So this map was drawn 1800s, I think, long before computers. Okay, they didn't understand at that point probably, here's this family of blue colors, which is compatible, and we'll throw in orange as a contrasting color, which is a great way to take advantage of what you can do now. The point I want to make is you can make great graphics even without that stuff. The point is, and this is the point that all three of our speakers made, I think, your graphics should tell a story. And you can tell a really great and really depressing story with a figure that was drawn by hand 200 years ago. That's including like 6 different layers of information on one picture. It's not using 6 different insets to show 6 different kinds of information. It's all on one graph. There's latitude, there's longitude, there's time, there's temperature, there's number of people. Anyway, I think it's a great example of, again, telling a very visual story with a figure. That's what your goal is when you're trying to illustrate. So, thanks to our presenters. One of them had to leave early. As always, we look for your feedback on these events. There's a thumbs up box, a thumbs down box with a very simple, interpretable graphic on it in the back there. If you have suggestions for other topics, please submit those. Thanks for coming, and we look forward to seeing you next time.
What do you think about that's my new favorite time?
I mean, I'm not